Hey everyone! So, of my previous YouTube videos, the one on domain and range proved the most popular. So I thought I'd upload a few more questions for you in preparation, well, for those of you that are preparing for their exams this summer. These are all taken from Edexcel, but if you prefer a different exam board, please let me know in the comments. I'm happy to post some more on these. And I've kind of gone back with these ones to find some tricky questions from the past, but they are still totally applicable to what you could be tested on this summer. This paper or this question is from January 2009, and we would say it's a C3 paper. So here we need to write down the range of G. I always say to my students to do a sketch when finding range on domain. It's time consuming, but it does guarantee the right answer instead of just guessing. If you've got the calculator that lets you draw a graph, then even better, but I don't have one of those and I don't expect my students to have one either. So I would always do a sketch, even though it's 1 mark. If you don't want to do it now, you can skip it and come back to it at the end of the exam if you still have time. There is a little bit of a clue in this one, which it is worth knowing, and that is for G, we know that it's a function with an x squared in it, e to the x squared. So please remember that the smallest a squared number can be is 0. 0 squared is 0. It can't be any smaller than that, because if you start squaring negative numbers, they just become positive. I am going to do a sketch, but you could get away without doing one for this. So it's e to the x squared. So I know what e to the x looks like. E to the x squared isn't really a transformation as such, because we know shifts and we know stretches and we know reflections. So it doesn't really fit into one of those because of the x squared, but I can just plug in some numbers. So if I plug in a 0, that will be 0 squared. E to the 0 is 1. If I plug in a 1, it will be e to the 1. If I plug in a 2, it will be e to the 4. So this right-hand side is going to look an awful lot like an e to the x graph. It's just going to be increasing more rapidly. On the negative side, if I plug in a -1, it's going to become 1, because -1 squared is 1. If I plug in a -2, it's going to become e to the 4. So it's actually going to be the same y values as on the right. So it's actually going to look a little bit like a parabola. And the domain is any real number, so I don't need to rub anything out. So looking at that, what's the lowest the graph can be? 1. What's the highest the graph can be? Infinity. So that is my range. Show the composite function fg of x is defined by. So this one's actually going to be quite nice and straightforward. We like composite functions. So f of g of x equals, so wherever I see an x, I'm not going to put x, I'm going to put e to the x squared. That's my new input. Ln and e cancel each other out, so I just get an x squared. And that's the show that. It does mention the domain, but that's not actually, confusingly, that's not part of the marks. We could write it down just to be sure, but we don't have to show where that comes from. So now we know the domain, they've given it to us. Write down the range of fg. So we've got to write down the range of that composite. So again, this isn't something we know how to sketch. An e with an x squared in the power plus an x squared. So it's 2 graphs added together. I don't know how to sketch that. So now we are actually going to have to use the fact that we've got these squared numbers. So the smallest a squared number can be is 0. So e to the 0, the smallest that can be is 1. So the smallest that can be is 3. And then over here, the smallest a squared number can be is 0, x squared, if x is 0. So therefore, the range, if we let x be 0, then we're going to get 3 plus 0. So 3 is going to be the smallest output we can have. And then it can go up to infinity. D. Solve when the derivative of the composite equals right-hand side. I'm just going to go straight in and differentiate that. Not going to waste any time. It is 6 marks though, which seems quite generous. E to the f of x, so you differentiate the power times by it, leave the power the same, equals okay. I'm just going to take my time with this. I'm feeling like we could cancel. We've got x's, but we need to be careful in case x equals 0 as a solution. So I'm going to leave them in for a moment, oops, and expand with them. 2x on both sides, so minus 2x from both sides. And then let's, if in doubt, make it equal to 0. Always a good idea to try and get your equation equal to 0. So now, rather than dividing, I'm going to factorise. So I can factorise out an x and an e to the x squared. That will leave me a 6 and a minus x. So we've got some solutions. Solve the equation. So we have x equals 0, e to the x squared equals 0, x equals 6. E to the x squared equals 0, so if you ln both sides, you're going to get ln 0, which is no solution. So I'll put a neat line through that. Okay. Next question. Find the inverse. So I'm not overthinking this too much. I'm just going to go straight in. Write y equals rather than this, well, this is quite strange f colon x notation. Rearrange to get x the subject. You might be able to do this quicker than me. We're going to need to introduce e to undo that ln. And then rewrite it with the inverse notation and swap the y's to x's. It's just a rule. It's like it enables you to find the inverse without overthinking it. Okay, I'm going to work here now. Find the domain of the inverse. Right, so we've got f of x and we've got f inverse. The domain of the inverse is the same as the range of the original. So I might do that because we know the original is correct. It was given. Maybe we've done some bad workings out. And that E graph doesn't look particularly fun anyway. So I'm going to think about the range of the original. To do that, I'm going to sketch it. Baby steps, ln graph goes through 1, 0, and now it's x plus 2 in the bracket. So we shift everything to the left by 2. So that's going to be intersecting at -1 now. Then there's a minus in front of the ln, so that's a y transformation. All your y's get times by negative. In other words, it gets flipped in the x-axis. I'm just going to put my asymptote in so I'm not losing track of where it is. Flip in the x-axis. And then finally, we're going to shift up by 4. So that one's going to be a bit harder to draw, really. I'll give it a go. I'll change colour. Might look something like that. I'm not positive on how exactly it's going to cross the axes, but I don't think I need to know. The main thing I need to know is we have a domain. X is bigger than or equal to -1. I don't know where -1 is. I did know at one point, but I think I've lost it now. So let's say that we are only focusing where the graph, where the x values are to the right of -1. So I can see that we're going to have an upper limit on y's and then no lower limit. Y's can just continue to go down as the graph goes down. So the question is, what's that upper limit? Well, the upper limit is when x is equal to -1. So if we plug that in, -1 plus 2 is just 1. So that upper limit is 4. Therefore, y is less than or equal to 4. This is the highlighted bit of the graph. Oh, and I need to be careful because that's the range of the original. So therefore, the domain will be x is less than or equal to 4. Not really a quick way of doing that. If you want to, if you're really stressed or low on time, sub in the limit of the domain. So sub in -1, but you're not going to know if it's the upper limit, the lower limit. So maybe sub in another value as well. So it could be -1, x can be -2, and then investigate whether the y's are increasing or decreasing. You can't judge it alone based on just subbing in one number. Another composite function question. Find f of g of x, f of e to the x squared minus 2. E to the x squared minus 2 plus 2. And I'm solving this. 2's cancel. Ln e cancel. I'm not solving it, I'm just giving it in its simplest form. Done. And then find the range. Oops. So it's a parabola, and if I draw it quickly, it's sad face and the y-intercept is 4. Don't care about the x-intercept because all we need is the range. Done. Last question. G of 5. Let's work out g of 5 first. 10 plus 5 over 2. 15 over 2. And then we need to do g of that. I might use my calculator now. 40 over 9. State the range of G. Okay, so this is a 1 marker. It appears to be a reciprocal graph, but it's not in the general form that we know how to deal with reciprocals. The way I like to do, we can identify one asymptote. We know that x can't equal 0 because of x minus 3 on the denominator. If you can't divide by 0, so x cannot equal 3. So that's one asymptote, but we don't know the other one. I'm going to show you how I like to do these. It's a little bit time consuming. So I like to write the denominator in the numerator, and you'll see why in a second. So x minus 3. So how do I balance the numerator? So it was 2x, so I need another x, and it was plus 5, so I need a plus 8. And then you can see I haven't actually changed the question. Why have I done that? Because now these cancel to give 1. If I write them out, I'll do it for you. So we'll write it out as 2 fractions over a common denominator. So these cancel to give 1, and I'm left with this. So it's still not perfect because we've still got an x in the numerator and the denominator, which I don't like. It's not good for sketching. So let's just apply that one more time. X minus 3, and then I need to have 8, so I need to add 11. And then remember, we're just going to cancel the x minus 3, so that's going to give us a 1 plus the other one is 2, and then we've got the 11 over x minus 3. So now this is really easy to sketch. We've got x's are shifted to the right by 3, asymptote will be at 3, y's are times by 11 and then added 2. Y equals 2 is positive, so it will be top right, bottom left. State the range, and we've got x is bigger than or equal to 5. So somewhere there will be x is 5. And so y is going to be just a little slither between, it can't go down to 2. It can just, because of the asymptote, and it can't equal it. And it can go up to when x is 5, which we already worked out. That was 15 over 2. Nearly there. Find G inverse stating its domain. 2x plus 5 over x minus 3. Let's make x the subject. I'm going to move my workings out over here. Take x out of the terms with an x in. And remember to use the inverse notation and swap your y's for x's. State its domain, so the domain will be the same as the range of the inverse. So therefore, x bigger than 2, less than or equal to 15 over 2. If you want me to do some more questions on this topic, please let me know in the comments, or if there's another topic, I'll be more than happy to answer some more questions for you. Otherwise, good luck in your summer exams, everyone. Bye.